Okay, how's everybody? Science time. And this is a unit I've had to leave life science, which we're going to get back to because life science is 50% of the task test. We're moving to physical science for a moment because when someone took a tape, we found some questions there from the periodic table and also pertaining to atoms and how they work and all of elements and all of that relationship in the physical world. So I'm going to dig into that for a few days. And because if any of you are taking the task exam coming up, I think it's a pretty good chance you're going to see some of these concepts. So switched over for you. We're going to switch back. So we're going to start today. I'm going to show you what we have in the world, and they are not the world, but the universe elements. And some of these elements actually did come from outer space. Some of them are very rare on the Earth and more prevalent in space. And then we have some that are common to Earth and to also another planet. Earth and Mars share some of the same elements. So if we look, so that's why there is a thought. I'm sorry, I'm going around and about. That's why there's a thought that um, life could possibly be sustained on Mars. And they also have found by looking at the way the land looks is that it at some time had lakes and streams. And so that's why and also they look at Mars as a possible place for people to live one day. And I don't think it's crazy to say that's probably sooner than later. As you know, we have 3 billionaires set to travel into space, possibly partly for their own curiosity and to say they've done something that unique. Some of that money could have actually been used on Earth. That's just my opinion, to do good things, but it is what it is. So here is our chart of elements. You see some people's faces there because they were named after either important government figures or the scientists who discovered the elements. This particular chart, is only showing 103 elements, but to date, I'm sorry, not 103, but to date, we have 118. And here we go, 118 elements. So we're going to, if you looked at the little video, it's 2 minutes long. It kind of gives you the background on what an element actually is, how it's defined. And then we're going to go into how to read this chart. We're going to explore the behavior of some of these elements. We're going to look at the weight of them, how light they are, how heavy they are, what forms they take on Earth, liquid, solid, gas, how stable they are as liquids, solids, or gases, how they react to other substances. So that is what we're going to look at, how they're combined, their composition. We're going to look at elements, which is really the smallest, um, most pure that you can break down a substance. For instance, helium, which is a gas, can only be broken down into helium. Let me go, it can't be broken down any further. And here where we have chlorine, it can't be broken down into any other compounds other than what it is, just chlorine. And here is carbon, and that's showing you a diamond. Whether it's charcoal or a diamond, that's pure carbon. It cannot be broken down into any other substances on the earth. So this is our chart. As I said, don't panic. We're going to break it down as elementary as we can get to the lowest common denominator, right? The simplest thought. We're going to start there, excuse me, and work our way to where we're supposed to be. Sorry. So what I have wanted you to do, to take a look at this 2-minute video, If you didn't do it before class, watch it after class. Your understanding will be deeper. I'm going to give you a little bit of information, basic information. Um, know that you're going to see this again. And look what I did. I took it off of a kid's page. Why? Because they broke it down into the smallest units of understanding so that we can get it. And when I say we, I mean me too. So here we go. We're going to start here and work our way up. So an element defined is a pure substance. I know this is distracting, and I apologize for the rest of this. But an element is a pure substance that is made from a single type of atom, and that's an even smaller building block of the substance. Elements are the building blocks for all of the rest of the matter in the world. And some examples of elements include iron, oxygen, hydrogen, gold, and helium. These are some common elements that you've heard of, I'm quite sure. So then what we have when we're talking about an element is the atomic number. And that is the number that each atom has as a proton. So you'll get a number which is an important number. And what that means is hydrogen, okay, is the first element and it has one proton. So it has an atomic number of 1. Gold has 79 protons in each atom. So it's as though you broke the atom into the smallest units. You're going to have the nucleus and the protons, right? So gold has 79 protons and it's in an atomic number of 79. Elements in their standard state also have the same number of electrons, electric particles, as protons. Talk about that later. And here is silicon, which is found in glass and sand, and it's also used in electronics. It has an atomic number of 14, which means that it has 14 protons in each atom, right? So different forms of elements. Let's take a look. Even though elements are all made from the same type of atoms, they can still come in different forms. Depending on their temperature, they can be solid, liquid, or gas. And they can also take different forms depending on how tightly the atoms are packed together. Scientists call these allotropes. One example of this is carbon. Depending on how the atoms fit together, they can form a diamond, a coal, or graphite. And graphite is the mineral that you see used for pencils. Then we have families of elements. And elements are grouped together in families when they have similar properties. Again, we're going to talk about these in a little more detail. So you have noble gases, and such as helium, neon, argon, krypton, xenon, and radon. They are unique in that the outer part of their atom is full of electrons, and that means they don't react much with the other elements. They are often used as signs as they'll glow in bright colors when an electrical current is passed through them. And you know neon lights, you see them everywhere on buildings. Then you have alkali metals. So they are very reactive with other elements. They have just one electron in the outer shell, and so they are reactive, and those are lithium, sodium, and potassium. And isn't that interesting that sodium and potassium are very vital to the balance in our bodies for health and well-being and life? So other groups are metals that are called transition metals, which means what? They're not stable. Then you have some that are not metal. They are halogens. There are alkali earth metals, actinides, and lanthanides. We'll go into it. We're not panicking. So how do we organize this information? so that we can understand their relationships to us, their relationships to one another, and their relationships to the earth and the universe. This is called a periodic table. And here are your noble gases that we talk about: helium, neon, argon, krypton, xenon. They're there. Then we have the others on this side where you have hydrogen, sodium, potassium. I don't remember what that one is. Those are related. Okay, so if you go down in the columns, they are related. Okay, we will show you how these are related and what all of these things mean. Finishing this part up, elements found on Earth and Mars are exactly the same. Hydrogen is the most common element found in the universe. It's also the lightest element. Isotopes are atoms of the same element with different numbers of neutrons. And in ancient times, the elements were called earth, air, fire, and water. And helium is the second most common element in the universe, but it's rare on the earth. But you think, but aren't there helium filled balloons all the time? Well, I'm sure if you think about the atoms being very far apart, because helium is generally in its gas form, and the earth is probably very little. Then, as you can see, how some of these elements are organized, we'll go much more into this. I think this is all we're going to talk about today. Take a look at that 2-minute video. You will find it to be very helpful. And we are going to look more at the periodic table and explore some of the elements a little more tomorrow. So that's all we have for now. All right, take care, and we'll see you tomorrow, hopefully for social studies. Be well.